Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss any single video.
In this short video, we're talking about logging. In particular, how to get our devices to send logs to an external server, which we can then use for troubleshooting. Network devices are capable of generating logs. The way this is handled though, depends on the vendor. Cisco routers by default will store logs in memory. These are wiped out when the router is rebooted. Juniper, on the other hand, will send logs directly to one or more files located on local storage. Something they'll all support though, is sending logs to an external log server, called a Syslog server, using UDP. Many different devices can send logs to a single server, making it possible for us to see if an event is affecting more than one device. Syslogs have a common format. Different vendors will put different information in their logs, but they are all formatted the same way. Here we have an example of a real log on a Cisco router, showing that an interface has come up. The advantage of using a common format is being able to use a single Syslog server for multiple devices and across multiple vendors. But why do we want an external Syslog server if logs still work locally on each device? There's a few reasons. We can archive logs, we can save logs if a Cisco device reboots, we can access logs in one central area, and we can correlate events between multiple devices. We'll now take a moment to look at how Syslog messages are formatted, but don't worry, it's not as boring as it sounds. Aside from the log message itself, there are two main components, which are the facility and the severity level. The facility represents the process that generated the event. Each facility comes with an ID number. For example, if a Linux server had a fault in its operating system, it might generate a Syslog message from the kernel facility. So, what is commonly used on routers and switches? Take a look at this table. See how there are local 0 through to local 7 facilities? These are kind of user-defined facilities. They are generic and not for a specific purpose like the others. Cisco routers and switches will use the local 7 facility by default, but different vendors may have different defaults. We can change the facility that we use if we want to. We'll see how to configure this a little bit later. Something of far more interest to us right now is the severity levels. Our devices may generate a ton of logs, some of which may be absolutely critical, while others may be relatively benign. Generally, there's more benign logs than critical ones, so the important logs can easily be drowned out. So, as you can see in this pyramid, logs are broken into 8 different severity levels. The higher up the level, the more important the log is. If we go back to the example we had before, we can see that this log relates to an interface going up or down. On a Cisco device, this is considered to be a level 3 event, which is fairly important and corresponds to the error level. Does this literally mean that the interface coming up is an error? After all, isn't the interface coming up a good thing? Don't worry, this is just the name of the level and doesn't always indicate that there is an error in a literal sense. The names we give to levels are really just to describe how important this log entry is. Now, here's a follow-up question. If you're looking to pass an exam, like CCNA, do you need to remember all of these levels? Yeah, sorry, you're probably going to have to remember them, and in order too. So, here's something that might help you. Think of the phrase, every awesome Cisco engineer will need ice cream daily. If you have another method of remembering this, please share it in the comments below. There are a lot of different Syslog servers out there. Some are free and some are paid for. And some are just a small part of a much larger package. Here is one I suggest for getting used to Syslog servers. It's called Kiwi, and there is a free version with limited features. Just make sure you get the right one. There is a free version and a free trial. I've selected it for this video as, well, it's free. It's easy to set up, and it runs on Windows, which is what I have right now. And this is what it looks like. Really nothing much to see here at this time, as we're not receiving logs yet. We can have up to 5 log sources in the free version, and we'll configure 2 of those right now. Here is the simple lab topology we're using. The Syslog server shown here is our Kiwi app. R2 has already been configured, and we're going to configure R1 now. Let's take a moment to look at local logging first. Right now, I'm connected to the console port of this router. Well, virtually connected, as this is a lab running on Viral. Logs are sent to the console port by default. We can see this if we enter configuration mode and then exit again. See this message that we get? Yes, this is a Syslog message. You've probably seen a ton of them in the videos throughout this series. This is a level 5 message, and is telling me that I've been configuring the router from the console port. However, if you connect to the router with an SSH session, you won't see these messages. You'll need to use the command terminal monitor, often shortened to termmon. If I do this now, it tells us that the console is already monitoring for new logs. But what if we want to see old logs and not just current ones? We can use the show logging command. As I mentioned earlier, these are buffered in memory. Let's move on to a Syslog server. As I mentioned in the last video, I highly recommend configuring the time correctly. First, we configure DNS, and then our NTP server. We're also going to configure the router to put accurate timestamps on each log. The key points here are datetime and msec. Datetime tells the router to use the time and date in the log. The alternative is the time since the router booted. msec tells the router to record timestamps accurately to the millisecond. We're finally at the point where we can configure the router to send logs to the Syslog server. Everything here will use the logging command. First, we configure the interface that should send the logs. This is optional, but sometimes we need it. We can also set the facility that the logs are sent from if we want. Just for fun, we'll set this to Syslog. Honestly, I never set this in the real world. I've never really had a need to. Now we can set the level of logs that we want to send. We usually won't want to send them all, as this can be overwhelming. So I'll tell the router to send everything from level 5 and up. And finally, the IP or hostname of the server that we're sending the logs to. Let's bring up our log server here, and we'll exit configuration mode. Remember that leaving configuration mode will generate a log. And there it is, a Syslog entry on our server. I recommend playing around with this to see if you can generate some more logs between the two routers, so you can see them both logging. As always, there's a downloadable lab if you want to play with it. And of course, we need to have a quick quiz, so see how you go on these questions.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly via our social platforms. Thanks for watching.